The ERJ145 series of aircraft are equipped with a steer-by-wire system for which a central computer is responsible for processing all inputs and providing the necessary nose-wheel steering deflection output. The steer-by-wire system features a comfortable operation at any speeds or amount of nose-wheel deflection. The purpose of this video is to provide additional information about how the ERJ145 series steering system works and to explain the possible failure modes and the proper operational procedures to be followed in the event of an uncommanded swerving. The objective is to provide information in a visual format so that all operators can adapt their training programs to improve awareness or proper emergency procedures in the event of a steering malfunction. The nose wheel steering is electronically controlled by the Steering Electronic Control Module, ECM, and hydraulically powered by Hydraulic System 1. The ECM is energized when the landing gear is down and locked and the aircraft is on the ground. The ECM processes all inputs. It computes the desired nose wheel deflection. Electrical power for the system comes from the DC bus 2. The nose wheel can be steered through the hand tiller and through the rudder pedals. The tiller and rudder pedals incorporate a potentiometer and responds to steering inputs and sends a signal to the ECM. In addition, the tiller incorporates a reset switch function, which is actuated when downward movement is applied to the tiller handle. By acting upon the handle, it is possible to re-engage the system if the system has been disengaged for any reason. When the tiller or pedals are moved, a servo valve in the hydraulic manifold is signaled to direct hydraulic pressure to the side of the steering actuator, corresponding to the direction of input, which then results in the desired steering movement. A feedback potentiometer in the nose landing gear leg transmits the associated displacement to the ECM, which recognizes when the desired displacement is attained to zero balance the turning input. The steering system can be disengaged either manually by switches on the yokes or automatically through the ECM in case of failure. A proximity sensor on the nose landing gear strut may also disengage the system if wheel angle exceeds 7 degrees for the rudder pedal commands with no input through the tiller. Whenever the system is disengaged, pressing the tiller will reset the rudder pedals. Turning the tiller enables steering displacement, as the tiller is always active. The steering off caution message appears if the ECM detects any failure, causing the wheel steering through the rudder pedals to become inoperative. The message also appears if the steering disengage button is pressed. Remember, this message appears only when the aircraft is on the ground. If a failure occurs in the feedback potentiometer, for example, the inability to read the correct nose wheel deflection, the resulting command to the ECM and the final nose wheel deflection can be wrong, maybe even reversed. This could cause an uncommanded swerving during which the aircraft will veer away from the runway centerline. In this case, the electrical failure leads to a fast deflection of the nose wheel, reaching 7 degrees of deflection in less than 1 second. The proximity sensor will then automatically disengage the system and the steering up message will appear. However, the hand tiller is still active and if used will bypass the protection, which in turn can exacerbate the veering tendency. To cope with this situation, flight crews should control the airplane using rudder commands and differential braking, rather than using the hand tiller. Pressing the trigger and the yoke will also be useful to prevent any additional veering tendency. Malfunctions of the servo control in the hydraulic manifold, such as fluid clogging, can also lead to an uncommanded veering tendency. However, this tendency is not as instantaneous, and the steering up message will only appear after the nose wheel reaches 7 degrees, which may take a few seconds. The only effective way to prevent a steering miscommand, in this case, is to press the trigger on the yoke. When it is pressed, hydraulic pressure is cut off, which disables the steering actuator. The nose wheel will then caster and center automatically. Simply avoiding the use of the tiller will not prevent a steering runaway situation in this case. Again, directional control is gained by using rudder pedals and differential braking. The above examples show that steering failures can have different symptoms. Indeed, the steering up message may or may not be present, and the steering and uncommanded deflection may happen quickly, causing a crisp lateral acceleration to either side, or it may happen gradually. The variety of symptoms can pose a challenge to a crew, since there may be other situations that produce symptoms that look like a steering malfunction when in fact there is no problem. Examples of such include lateral gusts, wake turbulence, or problems with the main landing gear or main wheels. Because of these variables, training must address the decision-making process in an event of a suspected steering malfunction. This means deciding very quickly whether in fact you have a steering problem. Information that can be helpful includes gusting crosswind, if the separation from the preceding aircraft was short, or if the yaw happened even before the nose wheel touched down. To emphasize again, if there is a steering problem, the aircraft can be controlled by using rudder commands and differential braking. Differential thrust reverser may also aid. Most importantly, pressing the steering disengage button ensures that there will be no uncontrollable veering, even if the cause is a hydraulic problem. The tiller should never be used, as it will exacerbate the tendency. Please remember that the emergency procedures to be followed are set forth in the AFM. Embraer is fully committed in providing the best possible support to operators and their flight crews. Please feel free to make any suggestions and to contact Flight Operations Support for additional clarification in regards to this video.